Again, welcome to class again today. And I'm kind of recording this now. So just a minute. Am I sure I like the transcribe? Because it doesn't quite do that much of an. Okay, well, I'm just gonna go with this. So what we have here is unit 3. So we've been able to go through unit 1, 2. I mean, there are remnants, things there that would, like I mentioned, we're going to be going back and forth with, because there's a level of connection between all of the units. But ultimately, most of the knowledge that we put together or gather will culminate in the building of the apps, right? So that's literally where we're headed. But we're going to be spending some time working on organizing data. This is so we're going to come back next week where I do a thorough job with unit 3. But what I'm going to do today is just skim around some of the things in unit 3, give us some kind of heads up so you can go do your own studying, reading, do the exercises, and then we come back next week and go through it again. And part of why this is important is because, you know, why it's important is because data, being able to understand data is very, very critical to being able to really do well with this, with programming and the sorts. So, okay, so I'm gonna proceed. This unit, what it does comprise of is it would help you learn skills for organizing and processing data. So, which is the point? A whole lot of things that happen around programming is really about collecting data, organizing data, processing that data, and outputting that data. So we're going to be able to understand data. We're going to be able to understand different data types. We're going to be able to understand different data structures, where they are used, how they are used, their features, and all of that. So we're also going to learn, like I just mentioned, about types, including the methods and properties associated with a type. Yeah, what exactly is a type, right? Learn how to create custom types with structs, and learn how to order data in arrays and how to process arrays using loops. Now, I go a little beyond what you have here because I begin to talk about other things beyond just arrays, and we're going to see that as we proceed. So specific applications for what we're going to do, we're going to be able to create old school pixel arts and animations, something we're going to use all of this information or knowledge we are gathering here to do. We will be able to extend the data visualizer that was built earlier in a previous exercise. We're also going to be able to create an algorithm to determine password security, then build an interactive bouncy ball app with colorful shapes, build an interactive prototype of your app in Keynote, and draft a user experience survey, which you can use later to test your prototype. So what we didn't quite do before we got into this class was the whole thing around the non-code aspects of developing an app. And if you had read through your reading for last week, you would have, seen how you gather ideas, put all of that idea into pen and paper, and then possibly put those ideas into Keynote, right? But I'm optimistic that down the line, we should be able to dedicate maybe one class or something to go through a chunk of that. But part of what I would be recommending, I'll probably send that in the email, is that there are like 2 videos, right, that were embedded in the course as part of your designing of an app that I'm going to send out. If you find some time, please do watch those videos. So getting started with organizing data. So there's something called collections, right, in Swift, right? Collections are literally sort of, would I call them data structures? But they are types. Let me call them types. And we're going to get to know more about what types are. They are types that are used for storing collections of data. You know, when we talked about things like character strings and all of that, right? We're dealing with individual data pieces. But what if I have a collection of values, right, that I want to store? How do I store them, right? And a typical example of what you call, you know, a collection of values might be what you have in your Excel sheet, right? You have all of these things and you want to figure out there are 100 kids. And what you're trying to do is to find all their heights. How do I organize that kind of data? And that's what collections are very good with. So they are used for storing collections of values. So a collection is a sequence, right, whose elements can be transversed multiple times. In other words, you can run through, so it's a sequence. Just think of a sequence. And I'm going to show us a diagram that would give you a typical example of a sequence whose elements can be transversed. So inside the collection, right, you have individual elements, right? So for the 100 kids I was talking about, you're looking for, say, their height. The values of their height will be something like 7.8 centimeter, you know, 100.1 centimeter. I don't know what that will be, but you get the idea. Those are the values. So if it's a collection, I can actually somehow run through all of those data elements, right, to as my way of performing an operation. It could be I want to run in there and add up things. So I want to go in there and multiply things. I want to go in there and look for the square root of everything, right? So a collection is a sequence whose elements can be transversed multiple times. You can go through them multiple times. However, it has to be in a non-destructive manner. When I've gone through them, I still have the data there. And then the other characteristic of a collection is that it can be accessed by an indexed subscript, and I'm going to show us what we mean. So this is an example of an array. For example, this is an array actually. So let's say I have this line of code, right? I say let names equals to, by the way, this is how you see the braces, you know, what would you call this? Like, is it like square braces? Yeah, square braces, right? That's how you declare an array. So once the compiler or the system sees this, it just takes it for granted, hey, I think we're in array territory, right? So so this is a constant, and these are, everything you have in here are the elements of this collection. So an array is an example of a collection, and I'm going to talk a little more about the different kinds of collections in the next slide. So let names equals to this, right? These are the elements, but each of them, right, has an address. So this could be you live somewhere in Ghana's Ferry, or you live somewhere downtown, or you live somewhere in Ermo, right? This is you, but then you do have an address. So the way they set this thing up, that address, right, is based on an indexing system that starts with 0, 1, 2, 3, 4, 5 to maybe infinity, right? but it doesn't start with 1, it always starts with 0. That can get very confusing for people that are new to programming, because it almost appears as if in our decimal system we are always starting with 1, but in reality you're actually supposed to start from 0. So you count 0 to 9 and then you increment and go back to where you have 0 under it. You now have 10, 11, 12. When you get to 19, you increment again and go back to 21. Almost something like that, right? That's what we have here. So if I'm asking you, what's the address of Mary? Mary lives on number 1 of this street. Where does Ben live? On number 0 of this street. So if you run this code yourself, which you can try, that's the whole reason why I put out this code sometimes. So let the names equals to this. So by doing this, I've created an array. But if I want to find out what is in address 0, if I run this and I say print and I put this, instead of writing my element, I'm now actually writing their address, right? It's going to give me Ben. If I say names and I type 4, it's going to give me Johnson. Why? Because Johnson lives on number 4 of these streets, which is 0, 1, 2, 3, 4. Boom. So to the point I was trying to make from the previous slide, I was saying something about that a collection is a sequence whose elements can be transversed multiple times. So I can go through all of these elements multiple times. It has to be done non-destructively so that after I've gone through it, I still have all of my elements. What else? It can be accessed by an indexed subscript. So these are my subscripts. I can access them, which is what we've been able to do here, without going here to go figure out who Johnson is. If I can just enter his address, I'm going to find him, right? So this is very important. Eventually, as you begin to program, you're going to see where indexing makes a whole lot of sense. So talking of collections, right? There are several types of connections, but the primary types of connections, right, in Swift are arrays, sets, and dictionaries. There's one more thing that I don't have here, because in a sense, I don't consider them like primary collections, and they are what we call tuples, right? So what I'm going to do, I'm not going to dwell a lot on these collection types. Maybe next week, I might expound a little more on each of them, because each of them has specific unique characteristics, right, that would have some consequences as you begin to program, or you begin to use them as part of your application development process. But I'm just going to touch on a little about them and then we'll jump past. So we talk about collections, right? And I talked about 3 main types of collections: arrays, sets, dictionaries. So arrays, right? One of the things to know about arrays are similar to what you have in other programs. For some of you that have done programmed in other languages, right? It's almost like your list. It's like your list in Swift. I'm not sure Swift has list, because I really haven't encountered that. You have arrays instead. But then what's the difference between 3 of these, right? Like arrays. So come this way, go back. Arrays would usually only handle the same data types. So what we have here is all strings. Ben, Mary, Hilda, blah, blah, blah. But you can't have Ben and then you have 2 here, because 2 is not a string. 2 is an integer. The only way 2 becomes a string is if you explicitly convert it to a string. So if you put 2 here and then you put, if you put Ben here and then you put an integer here, it's not going to work, because arrays do not accept, they only accept one type of data type, one data type, right? That's the thing with arrays. But the other thing about arrays is that they are ordered collection of values, and I'm going to show you what it means to be an ordered collection of values. Notice all these other ones, tuples are unordered, sets are unordered, and dictionaries are unordered. Like I mentioned, I'm going to show us what it means to be ordered or not ordered. So I talked to us about arrays. The next thing that is very similar to another type that is very similar to arrays will be the sets. Sets are primarily the same thing with arrays, right? Have a lot of the same characteristics except for two main things. Number one, in arrays, for example, let me go back, right? In arrays, I could have 2 Marys in an array, or I could have 4 Hildas. By the way, I mean, you could have so many people within a population that have the same name, Mary, for example. So I could have 10 Marys. But set would not accept that. If you have 10 Marys, set is going to report on only 1 Mary. So everything has to be unique. Each of the elements has to be unique in its own right. That's one difference between arrays and sets. Else, both of them are literally the same. They have the same characteristics. The second difference between them is that arrays are ordered collection of values, right? But sets are not ordered. They are unordered. Again, I'm going to show us what it means to be ordered or not ordered. Then, tuples are kind of interesting. Unlike arrays that can only accept one data type, a tuple can accept different kinds of data types. You can have a string here, you can have a character, then you can have, just name it, right? You can have all of that stored within a tuple. And you're going to see tuples. They're a little more complex, but you're going to see them. Sometimes they are literally looking like your function, just the same way you store properties in your function. That's sometimes how tuples behave. And then you have dictionaries. So think of dictionaries as, okay, look at this, key value association. So I'm trying to make an association between a key and a value. That's when I use dictionaries. Now think of dictionaries. When you open the dictionary, the first thing you see is you see a word and then you see the meaning. That's what a dictionary does. So normally you have a value, a key, and then the value. That's what dictionary is. So anytime you want to remember what a dictionary is, just go think about the dictionary. So for example, if I want to store things like name, age, somebody's name, their age, their date of birth, their hometown, blah, 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 I probably will store that with a dictionary, because what a dictionary does is it picks all of these keys and then associates values with them on the side. So if I'm ever trying to make an association between two things, right, that have a value, that have a key and a value, I probably will be thinking about a dictionary. But if I'm going to store a sequence of numbers, I'm probably not going to think about dictionaries. I'm going to think about an array. If I'm going to think of a sequence of numbers, right, that includes, say, music files, strings, and then integers and all of that, I probably will better serve to store it in a tuple. And that's why we have different types, because all of them have different characteristics. They behave in different ways. So whenever I want to be able to store my data, remember, all of this is literally about data. If I get my data, how do I organize it, right? And feed it to the system so that the computer, remember, a computer is essentially dumb. So for it to behave in a way you want it to behave, you need to give it the words in a way that's so broken down that it would understand. Just think of the app that we are looking at today. All of a sudden, the app is able to answer questions. Is it smart? Absolutely not. All you did is that you just created a set of logic, right, that makes the app, behave in a certain way because you asked it to behave, because you had pre-planned those responses and fed it to the system. So whenever you throw in an input, it's able to give you an output. But the big question is, how do we organize all of that data? What are the kind of structures, in this case collections, can we use to organize all of that data? So that's essentially what chapter 3 is about, trying to help us understand. So I already mentioned this. So this is where I try to make a distinction between an ordered or unordered, collections, or you can actually call them objects. A lot of the things, right, you're going to see in your programs, right, are designed around objects, right? So because eventually we're going to go talk about properties, and then we're going to talk about attributes. So properties are things like this, var. So I'm associating certain properties, but then you also have the methods or the behavior, right? So most objects have properties and behaviors. So a lot of the data types, data structures, and what have you, right, are also objects that have been created by the original folks that conceived the specific languages. So you have user-defined types, and then the types from the standard library. Those things from the standard library are essentially doing the same thing you're doing right now. They just happen to have created those things and stored them, So each of those things are literally like objects of their own. So look at these two. These are two examples, right? This is how you define a set. Same thing, right? This is a set, right? And this is where you define that it's a set. Remember, like the same way we do our strings, this is where you declare the data type that so we are defining a variable that is called students ID set, right? So let's say these are all the elements. Notice something about all the elements, right? They are organized 112, 114, 116, 118, 115. Then you have this variable. This has been declared an array, and this is what it is. Now, if you decide to print out this variable and print out this variable, guess what you're going to see? Pay close attention to the output, right? For array reports the same thing: 112, 112, 114, 114, 116, 116, 118, 118, 115, 115. So the array reports things exactly how they are, and that's why we call it an ordered set. So we have a specific order, and that order is not changing. But guess the thing about sets. Once you give sets, feed it some information, guess what? It goes about rearranging it. It goes about trying to rearrange the set. So, and I talked about creating arrays. Okay, so we already showed this in the previous slide, that if you want to create an array, all you use is your square blocks, right? And this is what I mentioned before, how arrays are used to hold single types. You can't use different kinds of types. So depending on what kind of elements it's holding, like in this case, right, we can say this is an array of integer elements, right? And then this is an array of string elements. This is an array of double elements because this is a double. These are all doubles. So I already talked about some of this. Yeah, I'll come back and talk some more about the tuples and all of that. Which now brings me to this. I know I mentioned this the last time, that most of the time, a lot of things that get fed into the system are looked as objects, right? So for example, if I want to model a dog and put all of the information, if I want to put a dog, right, a physical dog into a computer system, I have to figure out how to be able to do it so that when it gets into that computer system, whatever I put in that computer system is representative of the physical dog that I see today. How do I do it? I want to be able to find all the properties of that dog, and I want to be able to find all the methods or the behavior of that dog and capture it in some kind of textual form and then feed that data into the system, right? So the dog, for example, is a type, right? A type of animal. So it's a type. Usually you have a type, you know, and you have an instance of that type. And I'm going to get to some point where I show us that. But before I go there, I want to be able to mention what I think mentioned previously was like in Swift, there are different kinds of types, right? You have some standard library types. These are examples of some of the standard library types. There are user-defined types because you are the one that's going to create these types. Remember the structs that we saw in a previous class, you know, where we talked about structs. So we have classes. Some of you that are familiar with other programs and have done some object-oriented programming will be very familiar with classes. So you have classes, you have structures, you have enumerations, and you have protocols. These 1, 2, 3 are actually very, very popular. Well, eventually, we're going to get to know all of this, how to be able to set up those structures, what their syntax are, and we see specific applications of how they are used. But these are the standard library types, which we have already, you know, used and talked about a little bit. And then you have compound types, things like functions and tuples. So usually these compound types are typically a combination of 2 or more basic, and these are essentially, I would probably just two or more named types. That's why they are referred to as complex or compound types. So property. A property provides a way to associate values. So whenever, you know, go back to the dog, right? So all of these are properties of the dog: breed, color, but they don't tell us anything, right? They are like placeholders. I can now say colon, and then I would give it the name of the breed, which will be a string. The size, I can now give it the size, which will be some kind of integer. The age, I'll give it some kind of integer, right? So all of these are the properties, right? Which is why it says properties provide a way to associate values with a specific structure. What are our structures? A lot of these, you know, complex user types, right, are like data structures, right? So what we are doing when we provide properties, we are looking for a way, go back here, we're looking for a way to associate those values with a specific structure, class, or enumeration, right? So you have the structure, you have the class and enumeration. Like I mentioned to you, we're going to go talk about structures. And if you go into your Swift UI, you're going to keep seeing struct, that's structures. And the other thing I would mention before we get there, which I'm going to do eventually, is that structures and classes are very similar. They have distinctions, but at this level, you don't want to care too much about those distinctions. But of course, distinctions do exist. And then you have enumerations. Enumerations, I'm going to show us what enumerations are. But I mean, they are a very important part of your programming progress. Now, a constant or variable defined inside a class or struct are called properties. Remember your struct. So whenever I do something like this, right? This, for example, is an example of a class. So I start with this keyword, struct class. Then this is the name of my class student. And then inside that class, remember this is open parentheses and close parentheses, curly braces rather, braces, right? So this is what's inside this class. To define my property, I start with a var, the name of the property, and then the value of the property. Var, the name of the property, value of the property, value of the property, value of the property. That's what's going on here. So that's why I say the constant or variable. That's what a property is. It's a constant or a variable that's defined inside a class, and that's a class or structure. Those things are called properties. The other thing to remember is methods. So most of the types or the objects that you store in these types, right? Structures, most of them have properties and methods, properties and methods. Never forget that, because all through your programming journey, you're always going to be hearing about properties and methods. It's very important that you're very familiar with them. You're very familiar with what they do and how to manipulate them. What's a method? Remember how we went back, right? And we were writing the function for creating intelligence for our app. All we were doing there was just declaring data and manipulating that data using, say, for example, functions. Now, a method is actually a functionality within a struct, a class, an enumeration, or any other data type, right, that helps you manipulate the data. So it provides a behavior, right, to that object or that data structure or whatever. So that's why it says methods support the functionality of an instance in two ways. And I'm going to explain to us what an instance is. Right, but for now, just think of it like the object we just saw. It provides ways to access and modify the instance's property. So let's assume we create an instance, right? Right, so I've done this. If I want to call this, right, I'm going to go do, like we do our function call, I'm going to go make a call. If I make a call, here we just have placeholders, we don't have the value. We're going to pass those values, those parameters into this, right? And whatever you now get at that point is your instance. Just think of it like a mode. This is a mode. If I pass information into it, it's going to give me an output. So that's what a method is. It provides functionality related to the instance purpose. So remember when we did the lower class, right? That was a method, right? That goes in. Let's assume you have a string, a word, right? That dot whatever, it's a method, right? All it does is it provides the functionality and makes it possible for that string, whatever it is, to be converted into a lowercase. That's what a method does. So you can write methods for all kinds of things, right? And make them change their behavior or do things that manipulate the data in any number of ways. So think of it like your way of infusing intelligence, right, into your data structure, into your program, or whatever it is that you're doing. That's what a method is. So this is an example of a class, right? Forget about all the lines that I put around it, but just think of, you have a class called counter, open braces, close braces. So open braces, close braces, and then curly braces, right? Then the first thing is we declare that count is equals to 0, which is a property. We all agree that if it's a variable or a constant, that's a property. But then I'm trying to manipulate these numbers. So I create a function, right, to increment this number, right? If I count, if that number comes in, right, plus or minus literally means 0 plus 1 equals to some value, right? So when you see plus minus, it's just saying add this number to this number and then give me a value. That's, you do the addition and then you equals to is give me a value, right? So the first, if you run this the first time, is going to be something like 0 plus 1, which is equals to 1, right? And then it goes back. If you have 1, right, it will now be 1 plus 1 equals to 2, right? And then it keeps looping that way. What that has done, this method has created the ability to manipulate this property and give us some kind of result. This is another function, right? Same thing is happening here. Now it's incrementing the count plus some amount. And then here it's resetting at some point. It resets everything and takes us back to 0. Let me see. Someone asking a question. Correct. That's exactly what it is. So count is equals to count plus 1, right? So all of these things, right, that are here to manipulate this data are what you call methods. Structs, in Swift rather, structs, which is what we call structures, and classes are complex data types used to store and pass on different data types and their values. That's what they are. They are the building block of most programs, your structs and your classes. Structs and classes are used to define properties and methods that add functionality to your program. And I mentioned all of this, so I think we're going to have to stop here. It's exactly 8 p.m. So like I mentioned, this is very important. I'm going to go through it again, but I just wanted to give you some kind of heads up into the course. I'm going to have to complete the slide. I still have a couple of uncompleted parts of the slide. Complete that, and then next week we're going to go full blast, go through it, where we talk about objects, instances, methods, properties, and all of that, and show us how all of those things work together, like the structs. What are they? How do they work? How do they function? And all of that. Then we'll talk about instances. What are they? How do you create instances? So a whole bunch of things. All right. Any questions? I would assume no. Okay, please let's still go ahead and work on those exercises. Even if you get it the first time, I think it will be a good idea, to go through it a couple of times, and we will go from there. So I thank you for your participation today and your patience. Today was kind of slow. I haven't gotten enough sleep in 2 days, so I'm literally sleep deprived right now. So hopefully we get to see next week. So thank you very much.